Hello everyone, I'm about to create Pong from scratch here. From this point on I'll call it tennis just for copyright purposes, but it'll have the same functionality as Pong. Also, there are many ways to create this. I'm going to create what I think is the easiest way to do it, but if you have a more efficient way or you think something could be done easier, feel free to put it in the comments below. Thanks, and here we go. First class I'm going to make is the tennis class. Alright, we're going to create this as an applet, so I'll make this extend applet. Once we do that, we'll have to import. Then I'm also going to add in the basic methods we need for an applet. Now to use graphics, we'll also have to import graphics here. And now at this point, we can actually go ahead and run our applet. And notice here's our nice little applet, not very much to see. Alright, and we can code the update method first. The only thing that's going to go in there is just a paint G, so every time update's called it will just paint. Now let's actually start creating our applet. First I'm going to create two final integers called width and height. Make sure you use all caps since they're final integers, and I'll set it to 700 and 500. Then we can actually set the size of our applet, and I can say this dot resize. And we'll say width, height, and now let's go ahead and run, and now we've just enlarged our applet. Now let's create the backdrop for the game. It'll be a black backdrop with white paddles and a white ball. So we can just say g.setColor, color.black, and now we can go ahead and make the black backdrop. We can say g fill rect, and now this is just going to be the entire background. So 0, 0 starting at the top left of the applet. Then again we can just do width, height, and go ahead and run. There's our nice big black backdrop. The next portion that we're going to do is really just going to be set up for the other classes to be added in. So now we need to implement some interfaces. First one that we'll implement is runnable. This will make it a runnable applet. And then we can go ahead and add unimplemented methods. It's going to give us one method here, and it'll be the method run. Inside of run now we're just going to create an infinite loop. You can do this however you like. You can do while true. I'm going to do for semicolon semicolon. Now at the bottom of this loop, just so we don't forget about it later, I'm going to go ahead and put a thread.sleep, and we'll tell it to sleep for 10 milliseconds at the bottom every time. And after that I just surrounded it in a try catch. It is required that we catch this interrupted exception, since interrupted exception just extends exception rather than runtime exception. Now the next interface we're going to implement up here, and we'll just put a comment between the interfaces. Now we're going to implement key listener. Key listener is going to have 3 required methods. So first import key listener, then add the unimplemented methods, and you should have 3 down here: key pressed, key released, and key typed. Now we don't have to worry about key typed, but I will start on key pressed and key released a while. We're just going to create an if statement in here, and then inside of the if statement it needs to look exactly like this. e.getKeyCode is equal to key event vk up. Now vk just stands for virtual keyboard, and then you can specify the key that you're about to press right here. So this says essentially, if I press the up key, then do whatever's inside the if. And we'll have an else here. Let's just say an else if, and we'll change this to vk down. And this is just because for the user controlled paddle that we're going to use, I'm going to use the up and down keys. You could change these to whatever you like. If you like to use W and S, that'd be fine too. But now I'll just copy this format. I'm going to place this right into my key released as well. And then the next thing I'm going to do is just change these to E just to make things simpler. Now, just a couple more things we need to do up top here, and then we'll go into making our human-controlled paddle. First, we need to create a global variable that is a thread. So I'm just going to say thread. Now, inside of here, we can say thread equals new thread, and this wants a runnable object inside of here. Well, tennis itself is a runnable object, so we can just say new thread this. Also inside the init, I want to actually start the thread, so I can just say thread, call the start method. We also need to take care of the key listener while we're here, so we can just say this, add key listener. Again, tennis itself is a key listener, so this will be the parameter. One more thing to add, down in our run method, public void run, inside of this loop, right before we actually sleep, I'm going to call a repaint. So now this is the big engine that keeps running the game over and over. So this infinite loop, and every time at the bottom of the loop we'll repaint and then just pause for a 10 milliseconds, just so our eye can see the pause. Now, let's actually start the framework here for our AI paddle and the human paddle. First thing that we're going to do is create an interface just called paddle, and I'm going to put 3 methods in there, and here are the 3 methods. It's going to be draw, move, and get Y. Move and draw will both be void. Again, there might be an easier way to do this. In fact, if you made this an abstract class instead and used inheritance, it might be much simpler rather than just doing an interface. Next, we'll make a new class. We'll call it human paddle. And we're just going to make that implement the interface that we just created. And now that we've implemented, we can go ahead and add the unimplemented methods. So these are just the 3 methods that we coded in our interface. All we need to do now is provide the implementation for them. But before we code any methods, we need to create some global variables for this class. So we can go ahead, let's create our y and a y velocity as doubles, an up a cell and a down a cell as booleans, and then we'll just create 2 integers, a player and an x value. So now the x and the y represent the position of the actual paddle in the applet. The player just represents whether it's player 1 or player 2, so we can determine whether it's supposed to be on the left side of the applet or the right side of the applet. Then finally, these booleans, it can be up accelerating, meaning it's moving up faster, or it's down accelerating, meaning it's moving down faster, and if it's not accelerating, then we'll slow down. And the first method we're going to code is this get y down here, and the only thing we're going to do is just return the integer version of y, and there we have it. Now we can go ahead and create the constructor. The constructor is going to look like this. We have public human paddle, and we're going to take in which player is going to be either 1 or 2. Then while we're talking about that, if it's player 1, so if we're saying it's the first player, that means it's going to be on the left side of the applet, and then we're going to assign the x value to 20. If it's player 2, that means it's on the right side of the applet, and we're going to assign the x value to 660. While we're at it, we're going to set the y value to 210. It's just a nice center point for the paddle, and we'll also start it not moving as a y velocity of 0. The draw method for this is also quite simple. So we're just going to set the color to white, and now I'm just going to make it a rectangle, so I'll say fill rect, and we have an x already, we have a y, but be careful, the y needs to be cast to an integer for this method. And then in here I'm going to do 20 by 80. 20 by 80 gives us a nice vertical paddle. Now we just need to create mutators for the up a cell and down a cell booleans so that we can actually modify them within the tennis class. So we'll come down here, let's just say public void set up a cell. We'll take in a boolean, and we'll just set up a cell to the value of the input. Then we can do the same thing for down a cell. Again, just down a cell equals input. And now we've hit the point where we can actually go back to the tennis class and start adding this into the tennis class. But for now, we'll just leave this move alone, and once we have everything added into tennis, we'll come back and actually code the move method. Alright, first thing up here, we can actually add a new human paddle now. I'm going to say P1, then I'll finish instantiating inside of the init method. I'm going to put my human paddle on the left, so I specify a 1 here. If you wanted your human paddle on the right, you could specify a 2. In here, I can say P1.draw, and I'm going to pass graphics G as a parameter. And then inside of run, I'm going to say P1.move, because each time this iterates, it has to move that paddle. And we also have enough coded now that we can just come down here into our key pressed and key released and code these while we're here. So now we're actually going to use that set up a cell, set down a cell. So this one's key pressed and we're pressing up, so we want to set the up acceleration to true, meaning that when you press the up button, it starts accelerating to the top of the screen. Then we can do the same thing. Let's just grab this, we'll paste it in the key released, and once you release the key, we want to set it to false. And now we can do the same thing, we'll just do it down. So set down a cell, true, we'll copy this again, paste it down here to false. Now we've hit the point where we should be able to run the applet, and good, it's starting to look a little bit like our tennis game should. And we have one paddle here, this will be our human paddle. We can't move yet. If you press any keys, it won't do anything. But let's hit stop, and now we can go to human paddle and finish coding the move. So now in the human paddle class, go to the move method, and we're going to start with a series of chained ifs. So let's say if up a cell, and then we'll have an else if down a cell, and then finally we'll have another else if not up a cell and not down a cell. Alright, so now inside of each of these we're going to affect the y velocity, or how fast the y position is changing. So if we're going up, we're accelerating upwards, we want to change the y velocity and make it smaller, because 0, 0 in an applet is in the top left, so we want to say minus equal to. In here we can just copy and paste this guy. If we're going down, we want to say plus equal to. And for this last one, if we're not accelerating upwards, we're not accelerating downwards, we want our paddle to automatically slow down. And we're going to use a gravity coefficient. You could also use a friction coefficient if you want to think of it like that. But I'm going to say y velocity, and now I'm going to do times equal, and really we're just going to multiply it by something less than 1. If you multiply it by something less than 1, that'll force it to get smaller over time. So I'm going to call it gravity. We haven't created gravity yet. I'm going to go up to the top and create it now. All this is going to be is just a final double variable. Remember, all caps for a constant, and I'm going to say 0.94. And now we're about at the point where we can finally move our paddle, but we need one more line, and that's going to be, we're going to alter the y position by plus equal the y velocity. So we're just going to add that y velocity over and over. Now we should be able to run, and we should be able to move our paddle. So just make sure you click in the applet. You should be able to move up and down. The paddle will move very quickly right now. Alright, so now at least our paddle moves, but now it moves outrageously fast and it can move off the screen. So first let's handle the speed issue. We can handle the speed issue just with a set of ifs. So we can say if y velocity, I'm going to say if it's greater than or equal to 5, I'm just going to cap it off at 5. Y velocity is equal to 5. So if it goes past 5, we'll just bring it back down to 5. And I'm going to say else if y velocity is less than or equal to -5, I'll do the same thing. I'm just going to say y velocity is equal to -5. We'll keep it at -5. Now let's go ahead and run, and that should slow it down a bit for us. Yes, that slowed it down nicely. And now we can use if statements again just to stop it from going off the screen, but this time we'll just be modifying the y. Remember, y just represents the position, so we can say if y is less than 0, meaning if the paddle has gone off the top of the applet, then we're going to just put it back to 0, y is equal to 0. Alright, so that should handle the top. Now let me run, we'll make sure that the top works. If I go up to the top, very good, I can't go past that. Now the bottom is a bit trickier for knowing which number to use. Remember, our paddle is 80 tall, then our actual applet is 500 in height, so we have to take it down to this point and no further, where the paddle is down at the bottom and this is touching the bottom of the applet. So we need to remember though that when we specify something for the paddle or a Y position for the paddle, it goes off the top left corner. So now it'll actually be 500 minus the 80 for the paddle, so it'll be 420. So we'll say if y is greater than 420, then we'll just set it back to 420. Now let's run one more time, make sure that it stops at both the top, there's the top, make sure it stops at the bottom, there's the bottom. Okay, so now we have a human paddle that we can fully control. It stops at the top, stops at the bottom, and it accelerates and decelerates. Alright, now we've hit the point where we can create the ball class. So let's go new class, we'll just call it ball. Now the ball class is going to have an x velocity, a y velocity, and also an x and a y position, and we'll make these as doubles. Then the first quick methods we can put in here, let's just make accessors for the x and the y position, and we'll return these as integers. Just remember to cast when you return. Now we can go ahead and code the constructor. It's just going to be public ball, no parameters. Inside of here now, I'm just going to initialize those 4 variables that we had up there. So x and y just for the center of the screen, and then x velocity I set to -2, y velocity I set to 1. So this just gives us a nice slow angle for it to start with. We can go ahead and code the move method. Just going to be public void move, no parameters. In here, all we're going to do is just update the x and y position. So x plus equal x velocity, y plus equal y velocity, and there's our move. And we'll need a draw method just like the other classes we've been making. So we need a public void draw. As a parameter, we'll take in a graphics G, and we'll need to import. First thing I'll do in here, I'm going to say G, set color. I'm going to set it to white just like my paddle. And now I'm actually just going to create a circle that's filled in that's 20 by 20. So G.fill, it's actually fill oval method. And then I'm going to make it 20 by 20. And now for the x and the y position, we're going to do something specific here. First, we need to cast our x position and y position to integers. And then I'm going to subtract 10 from each of them. Now, the reason I'm doing that is because when this draws, meaning when the graphics draws a circle, it draws it from the top left corner. So if it were to draw a circle, the x and y position represent the top left corner of the circle. We don't want that. I want the xy position to represent the center of the circle. So if it's 20 by 20, meaning it's a 20 by 20 oval, or really just a circle with diameter 20, then I want the center to be 10, 10. And we can do that simply by subtracting 10 from both the x and the y position. And now we're ready to officially add the ball to the tennis game. This is nice and simple. All we need to do is say ball b1. We can instantiate, say b1 equals new ball, no parameters. We'll need to draw the ball. We can say b1.draw. Pass g is the graphics. And we'll just make sure the ball moves. So we can say b1.move. And now we should be able to run The ball will be moving, but it will be able to go off the screen and the paddle won't be able to stop it. There goes the ball. Even if the paddle would have been down in time, we wouldn't have been able to stop the ball. And now we can go back and stop the ball from going off the top and the bottom of the screen, and we'll just do that with a series of ifs. We'll say if y is less than 10, this will be the top of the screen. Remember that the center of the ball is 10, 10. So if y is less than 10, then we're just going to take the negative of the y velocity. So y velocity is equal to the negative of that y velocity. And what this does is, let's say our ball is traveling to the top, it hits the top edge, then we want it to start going back down, and that's what that y velocity equals negative y velocity does. And we can do another if. Let's say if it's greater than, the bottom will be 490, because remember the total height is 500, and then we'll just do the exact same thing. We'll take the y velocity, set it to its negative. Alright, and now we can test and make sure that this works by going up to our constructor, and we can modify these x and y velocities so that we make sure that the ball hits the top or the bottom side. In fact, I'm just going to set this to 0 so that the ball should just bounce up and down. And now we can go ahead and run. There's our ball, it's moving nice and slow, hit the bottom, bounce back, it's going back up to the top, and the top looks good as well, so now we can kill that. And now we're going to handle if it goes off the left or the right side, and this is what we'll do. If it goes off the left or the right, we're just going to display game over, and that ends the game for now. There are many things you could do. You could add points. You could add a point to the left side every time that it goes off the right side, and so on. But for now, we're just going to end the game, and it'll just be essentially a game to 1. So to do that, we'll just go into tennis. We're going to go into the paint method, and we'll add an if statement in here. This if statement is going to be added after we draw the backdrop. So there's our backdrop. Now we can say if, and we're going to be basing this off of the position of the ball, which is the x position. So if b1.getx, we're going to say if it's less than negative 10, or if b1.getx is greater than 710, because 700 long, so 10 would push the ball completely off, and negative 10 would push the ball completely off the left side. So if it's completely off, then all we're going to do is draw g.drawString. We're going to draw the string game over, and let's put it just right in the center, 350, 250, and we need to change the color so that we can actually see it. So g set color, and I'm just going to make it red. Now otherwise we'll do what we initially were doing, which is drawing the ball and the paddle. And now we can check to make sure that this works. Just go back to ball. We had our x velocity set to 0. We can just change that guy to 4 now. Go ahead and run. There it went right off the screen. We can check the left side as well. Let's set it to negative 4. Run it again. There it went off the screen. Again, we're good to go. Kills both the paddles. And now the next logical step would just be to check for a paddle collision. So when it starts and the ball goes to the left, if our paddle would be there in time and the ball would hit the paddle, we want the ball to bounce back to the right so that we can continue playing the game. So now, in order to do that, we're just going to have a void method in here. So it'll be public void check paddle collision. And now, as parameters, we want to take in paddle P1 and paddle P2, because we need to know the location of those paddles. So this method's actually going to be called inside of the tennis class, and you'll be able to say ball B1.check paddle collision, then you'll have to pass P1 and P2 as parameters. Now inside of here, I'm going to change this to 0. We need to figure out what bounds the ball is going to have that we need to check for. In other words, at what x point is the ball going to need to turn around if it hits the paddle? Well, this distance right here is 20. We know that from when we made the paddle, and then we made the paddle 20 by 80. So this is 20. The edge of the paddle will be another 40, but then the ball has a diameter of 20, so its radius would be 10. So when the ball is at x of 50, it's actually touching the paddle. So that'll be our first if. We'll say if x is less than or equal to 50, And while we're here, let's just do the else if as well. And now the else if will be the other side. It'll be over here. Remember that the edge of the applet is 700. We'll back off the other paddle by 20, so that'll put us at 680. We need to get to the other side of the paddle. That'll put us at 660. Then remember our ball has a radius of 10, so that'll put us at 650. So the else if will say else if x is greater than or equal to 650, and those are the x bounds that we need to check. And now the next thing we need to do is compare the y value of the ball to the y values of the paddle. And what I mean is that if our ball is traveling to the left, once it hits our 50 value that we said, then we need to compare the y value here of the paddle and the y value here of the paddle and make sure that the y value of the ball is in between that range somewhere. If it is, then we're just going to reverse the x velocity, send it back the other way. So here's how we do it. We're going to say another if statement inside of here, and we'll say if y is greater than or equal to p1.getY and y is less than or equal to p1.getY plus 80. Remember our paddle is 80 tall. And if it is, then all we're going to do is say x velocity is equal to negative x velocity. And now that we have it done for the left paddle, we just need to do the same thing for the right paddle. It'll be the same thing, comparing y, except now we're going to use paddle 2 instead of paddle 1. And inside here again, we're just going to do the exact same thing. X velocity is equal to negative x velocity. Whichever way it's going, we just want to reverse it. Alright, and now we're almost there. Now let's go back to the tennis game. Go down to the run method, and inside the run method, after we move, we now need to check for that collision. So now we can say b1.check paddle collision, and now we're going to pass p1, p2. Now we don't have a p2 yet. Once we make that guy, we can pass him, but for now we can just pass two p1s just to see if it works. Go ahead and run. Let's change the x value of the ball first. Let's head it to the left nice and slow. And now put our paddle down here and see if, there it is, and that bounces back our ball. And now you've probably been wondering what we're going to do for this right side here. Nice easy thing to do would just be to add another human paddle, which you could do, and then assign it keys so that one controls the right human paddle, one controls the left human paddle. That would be nice and easy, and then you can make it a two-player game. We're not going to do that. We're going to make an AI paddle for the right side, and the AI paddle is actually just going to track the Y value of the ball, so it will be an unbeatable AI. And here's how we're going to do it. I'm actually going to copy everything out of human paddle, and then we'll just delete what we don't need. Now I'll come down here, I'm going to create a new class. It's going to be called AI paddle. And then we'll paste, change it to AI paddle, change the constructor as well, and this will give us a nice starting point. Alright, and now I think you'll be amazed at how unbelievably simple this is. The first thing we're going to do is just add in a ball, B1. Remember, this is going to track the value of the ball, the Y value, so we're going to actually need to pass that in the constructor when we create this AI paddle. So again, we'll say ball, B. Now in here, we'll just say B1 is equal to B. Very good. All of this can actually stay the same, that's fine. Draw can stay the same. Now, in move, we're going to make some big changes. We don't need to worry about up acceleration, down acceleration. In fact, we can get rid of those methods entirely because we're not being controlled by a human user. All we're going to do is say y is equal to b1.getY. Then we're going to put a minus 40. Because a minus 40 will take where the ball currently is and move the AI paddle up halfway so that the paddle is centered on the Y value of the ball. And that's it for our AI paddle. So now let's go to the tennis game again. So we have human paddle, now let's say AI paddle, P2. We can instantiate inside of the constructor. P2 equals new AI paddle. And now we're going to say, remember, it's the second paddle, it'll be on the right, and we also need to pass B1 as the new ball. So B1's instantiated down below there. I'm going to put it down below. Good. Now, next thing we need to do is just add in the draw. So we'd have to say P2.draw, G and P2.move. Remember to change your collision in here. So now we have a P2, now we can add it in, and now we should be good to go. So let's go ahead and run. We're going nice and slow. Watch our AI track the ball. Very good, the ball reflects. Now the ball should bounce off the AI as well. Looks good. Alright, and we've almost finished up here. The next really big thing that we need to handle is that we need some sort of start button, so that when we start the applet, the ball isn't already moving towards us. We want to start the applet and then be able to say hit enter, and then that will cause the ball to start moving. And this is nice and easy to do. Let's just go up to the top. We'll create a boolean called game started, and in init we'll say game started equals false. Down in key press now, we're going to add another else if, and we'll say e.getKeyCode equals, there is actually a key event vk enter that we'll use. So now if it is enter, all we're going to do is say game started equals true. We can make a few modifications inside the run. We'll just say if game started, then we'll move and do all of this, but if it's not started, we aren't going to let anything move. Very good. Now let's run. Okay, looks good. Nothing's moving. We should be able to hit the enter key now. There we go. That started the game, and that started us out. We should also provide the user a nice interface, or at least some directions on how to start the game. So I'm going to go down into Paint, and I'm going to make an if statement that say if not game started, meaning that we haven't started the game, then I'm just going to add some strings in here. I'll say tennis, and I'm going to say press enter to begin, and I have these values at 340, 100, 310, 130. I just pasted them in to save some time. I also set the color to white just so we can see it on our black background. If we run this now, there we have our nice little press enter to begin. Again, it just starts the game, then it goes away after it's been started. Okay, and now the very last thing we'll do is I want to set the ball up so that when you hit enter, it has a random speed and a random direction. So we'll go back to ball, and this is all going to be handled within here, but we're going to create a few helper methods just so we don't clutter up our constructor. So let's create two helper methods, and then these will be used to determine the starting x and y velocities. I'm going to create two of them. The first one will be get random speed. The second one will get random direction. So first public, we're just going to say double get random speed, and we're going to just return a random, and we're going to say times 3 plus 2. That should give us first. This will give us a range from 0 to 3, not inclusive on the 3, then adding 2. That should give us 2 to 5, not inclusive on the 5. So that looks good. Now let's do the direction. For this one, it's just going to be an integer. It'll be -1 or +1. So get random direction. Now for this guy, I'm going to actually create an int rand is equal to int math.random, and I'll just say times 2. Now doing this creates a random number, either 0 or 1. Now if it's 1, I'm going to just return 1. Otherwise, I'm going to return -1. All we're going to use this for is we're going to multiply it by either 1 or -1. So it will either be going to the left or it'll be going to the right. Now that we have both of these made, let's just go up to our velocities. We'll say get random speed times get random direction. And let's just copy that. And we'll paste it in the y velocity. And now we should be able to start this off, and we'll have a random x and y velocity to start with. Okay, so let's run. We'll hit enter. We're going up and to the right. That looks good. Let's run it again just to make sure it's truly random. We'll hit enter. Now we're going down and to the right. Looks good. Now that's as far as I'm going to take you as far as functionality of the game goes. There's many more things you could add, but that's as far as we're going to go in this video. The next big thing that we have to fix though is this blinking effect that you see. It looks a bit ugly. It looks like all the words are blinking. In fact, when you move some of the paddles, once we start the gameplay, it looks like the paddles are blinking depending on how quickly you move. But so we're going to fix that, and here's how we fix it. First thing we need to do is realize what's actually happening, and let's go into our paint method. So what's happening is this is first painting the black background. Every single time it's painting this big black rectangle. So it paints the big black rectangle, then it goes through and then it paints all the paddles and the ball. So every single time it paints the whole screen with that black background, well at least the whole applet. We want to stop it from doing that. That's what's creating that blinking effect. What we want it to do is actually paint it on an off-screen buffer and then just take that entire off-screen buffer and then replace it, almost like a cartoon flipbook, so only small changes occur at a time, and that will get rid of that blinking effect that we're seeing. And now we can actually create our own off-screen buffer, and all it is going to be an image object that we draw, and then we'll just draw that entire image inside of the paint method. So the first thing that we need to create is a second graphics. I'm going to call it graphics GFX, and a new image. So I'm going to say image img. Now you'll probably have to import this. I already imported it from Abstract Window Toolkit. Now that we have those, go ahead, go down into init, and we're just going to create those with these two lines right here. It's going to be image equals create image. We're just going to create an image that's the size of our width and our height of the applet, and then we're going to get the graphics of that image so that we can draw on that image. So it'll be gfx equals image.getGraphics. Once you have those two lines, now we can start modifying our paint method. All of these G's in here we're going to change to our off-screen graphics. So we're going to draw all of these off the screen. So GFX, make sure you get these guys too, GFX, 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 GFX. So remember, GFX is the off-screen, then G actually paints what we're going to see. So once you have all of these being painted to the off-screen, now there's one magical method called draw image, and it's going to take in an image, which we have, img. We're going to start it at 0, 0, and we're going to pass it an image observer, which is this. And now that should do it. So when we run, our text looks nice now, very good. We should be able to start. There shouldn't be any flickering of the paddles. Nope, those look nice. Everything looks nice and smooth. Very good, okay. Alright, but that's as far as we're going to go with this video. So if you have any comments or want to know how to take it further, or you think a portion of my code could have been written a different way, please feel free to comment. Thanks for watching. I hope this helped you out.